Okay, so um, Unit 5 is our first trigonometry unit. The trigonometry is actually split over 3 units because it's such a big topic. Okay, so in the first trigonometry unit, we sort of are going to go over the kind of like the basics of the trigonometry, which we will build on in the following 2 units. Okay, so what we're going to do is we're going to use this circle on a coordinate plane to help understand various things. Okay, so we want to write the angles in what's called standard position, right? Because, okay, so you guys know what a right angle is, right? It's sort of like a corner, but, this is a right angle, this is a rotated right angle, right? This is a right angle, this is a right angle, right? There's many different ways I could draw a right angle. So in order to let us refer to the same thing, we can put angles in what's called standard position. Okay, so why don't we just go ahead and quickly define that? We can do it up here. So in order for an angle to be in standard position, what that means is that one side of the angle is on the positive x-axis. Okay, so with that requirement, we can make sure we're all talking about the same thing. Okay, the formal definition is a little bit more complicated than that. I'm just kind of simplifying it because we don't have all the words needed yet. Okay, so on this circle, which is on a coordinate plane with axes, first 0 degrees. Okay, so it's kind of silly to think about a 0 degree angle, but let's just go with it. Okay, so we have to start on the positive x-axis, right? So one side of the angle, so here's the x-axis, this is the negative side, this is the positive side. Okay, so the positive x-axis would be over here, right? And we know that an angle has 2 sides to it. Okay, so we already have one of the sides. Okay, so 0 degrees means the angle doesn't open at all, right? So it's kind of hard to represent, but so you have your first side, you open 0 degrees, and your second side, it would overlap it, right? It wouldn't go anywhere. It would still be in the same place. Okay, so that's a 0 degree angle. Okay, so 0 is always a weird number, right? Hopefully the following ones make more sense. Okay, so let me get rid of that. Okay, so next, what about 180 degrees? Okay, so again, we are always going to start on the positive x-axis. And this time, right, this time I do want the other side to sort of open up so that it has some space because it's not 0 degrees anymore. Sorry, I'm trying to use technology to make, whatever. Okay, pretend these overlap. Okay, so, right, I want to make this basically open up, right? I want to rotate it to form a bigger angle. Okay, so how far am I going? I need to do 180 degrees. Okay, so 180 degrees, well, here's 90, right? So 180 would be double that. Okay, so 180 would go all the way to the other side. Okay, so another way you can think about it is that a full circle is 360 degrees. So half of that, 180 degrees, is halfway around. Okay, so we label this point over here as 180 degrees. Okay, so the reason that this point represents 180 degrees, though, is if you start on the positive x-axis, and then the other side hits this point, the angle that's formed is a half circle or 180 degrees. Okay, so next up, 360 degrees. Okay, so 360 degrees, well, I just told you, 360 degrees is a full circle. So you start on the positive x-axis, but then you go all the way around, and you end up where you started. Okay, so 0 degrees and 360 degrees are actually the exact same point. They're both directly to the right of the origin. Okay, so those are the first few angles. Now we're gonna take those angles and convert them to radian. Okay, so I think many of you were introduced to the concept of a radian in your previous class. Does anyone think they remember like a description or definition of what a radian is? Yes, Rebecca? Uh-huh. Yeah, so that's good. And then there's a little bit more to it. Once you wrap it around the perimeter, what happens? Or what do you do? Yeah, so it's the angle that's formed when you do that. Okay, good. So let me go ahead and show you a little animation that I think helps visualize what Rebecca just described. Okay, so make sure you're looking up here, please. Okay, so, right, so we know the red line represents the radius. Okay, so like Rebecca said, you wrap the radius around the circumference. And if you connect the endpoints to the middle, that angle that's formed is 1 radian. Okay, so a radian is an angle measure, just like degrees. Okay, so you can see 3 radians is almost half a circle. So pi radians is half a circle. So if you double it, 2 pi radians would be a full circle. Okay, so again, just like you can measure a distance in both inches and centimeters, you can measure an angle in both degrees and radians. Okay, at the moment, you probably much prefer degrees because that's what you are much more familiar with. But we'll soon find that most calculations work a lot better in radians. Okay, so we're gonna sort of slowly start shifting over to using radians. Okay, so the main thing that you want to remember, if nothing else, is that a full circle is 360 degrees, but it's also 2 pi radians. Okay, for radians, we don't usually write the unit. We don't write like RAD like you saw in the animation. If there's no units, it's assumed to be radians. Okay, so I'm gonna relabel. Okay, this 360 degrees, we can also call this 2 pi radians. Okay, well, what about over here? Well, if you don't remember, you can just do a quick calculation, right? This is an equation, so you're allowed to do an equal action to both sides. So if you can just remember that 360 degrees is 2 pi, you could divide both sides by 2. And 180 degrees would be equal to 2 pi over 2, or just pi. Okay, so 180 degrees is pi radians. Okay, 0 degrees is 0 radians. Okay, and then over here, do the same in approximate radians. Okay, so we're not going to do this too much because, like I said, you don't have a calculator, but it's good to just have like an estimate. Okay, so you guys remember that pi is an irrational number. The decimal goes on forever, but it's approximately 3.14, right? So we can estimate 2 pi as 2 times 3.14. Okay, so it's about 6.28. Okay, and then back over here, it's simply pi. So again, we know pi is approximately 3.14. Okay, we're not going to do it for 0 because it's exactly 0. Okay, so let's do another angle. How about 90 degrees? Okay, so there's a couple ways you can think about this. We already know where 0 is. We know where 180 is, right? So to get from 0 to 180, you go halfway around the circle. So halfway to there, half of 180 would be 90, right? So halfway would be right here. Okay, and we mark it up here, the 90 degrees, but what it represents is the angle formed by the positive x-axis, and the line hitting that point is a 90-degree angle. Okay, so what about 270 degrees? Well, again, there's different ways you can think about this, but okay, this much was 90. So a quarter circle is 90 degrees. So this is another 90, and this is another 90. So added together, 90 plus 90 is 180, plus a third 90 is 270. Okay, so at the bottom of the circle will be 270 degrees. Okay, and again, let's just do exact radians. Let's not worry about approximate. Okay, so how many radians is 90 degrees? Well, we can build off what we had earlier, right? So we already know that 180 degrees is equal to pi. So we want to get from 180 to 90. So we just divide by 2. Okay, 180 degrees divided by 2 is 90 degrees. And over here, this doesn't simplify, so just leave it as a fraction. Pi divided by 2 is pi over 2. Okay, so now what about 270 degrees? So here it's not so easy, right? You can't really divide 360 degrees easily to get to 270 degrees. But it's not just dividing. You can also multiply both sides of an equation, right? So let me build off the 90 degrees equals pi over 2. So to get to 270 degrees, I could do 90 degrees times 3. Okay, so I'd have to multiply the other side by 3 also. Okay, so remember, this is regular multiplying. It's not cross multiplying. Okay, so pi times 3 is 3 pi, 2 times 1 is 2. So 270 degrees is equal to 3 pi over 2 radians. Okay, and again, what this actually means is the reason this point is labeled 270 degrees is the angle formed by the positive x-axis and the line hitting that point. This big angle would be 270 degrees. Okay, next up, 45 degrees. Okay, so you might recognize 45 degrees is 90 degrees divided by 2. Okay, so exactly halfway between 0 degrees and 90 degrees is going to be 45 degrees. Okay, and again, what this means is if you were to draw in the angle with the positive x-axis, the angle formed in the middle would be 45 degrees. Okay, so I'm gonna give you some time now to see if you can continue from here. Okay, so there's a few more angles in this section that I'm asking you to place. And there's a lot of angles in this section that I'm asking you to place also. But there's a pattern, right? So it should be not calculated one by one. Okay, and then for each of these angles, convert them to exact radian as well. Okay, so don't worry about 3.14. Just leave the pi symbol in the radians. Okay, so I'll give you some time to try this out. Let me know if you have any questions. 970 degrees. Again, the degree symbols cancel out. You can divide by 10, which cancels the trailing zeros out. 97 and 18. Those don't have anything in common. So by the way, for radians, we pretty much always use improper fraction. We would not use mixed numbers. Okay, how about 210 degrees? So this time we can not only reduce the degree signs and the 10, 21 and 18 can both be divided by 3. Okay, so 7 pi over 6. And then 40 degrees. 4 and 18 can both be divided by 2. So 2 pi over 9. Okay, so that's degrees to radians. We can also convert the other way. So if we continue on. Okay, so convert pi over 18 radians into degrees. Okay, so again, you might not remember at the moment, is it times pi over 180 degrees or 180 degrees over pi? Well, if it were pi over 180 degrees, you would have pi times pi, right? That would be pi squared. The pi's would not cancel out. Okay, on the other hand, if you flip it upside down, now that 1 pi is in the numerator and 1 pi is in the denominator, now you can reduce. Right, so the pi's divide away, 18 goes into 180 10 times. Okay, so pi over 18 is equal to 10 over 1, or just 10 degrees. Okay, so go ahead and try out the other 3, please. Negative 3 pi over 2 times 180 degrees over pi. The pi's cancel out. 2 goes into 80 90 times. 180 90 times. Okay, so negative 3 times 90 is negative 270 degrees. And the denominator is invisible 1. Okay, over here, 21 pi over 4. Okay, so the pi's cancel out. Now the 4 and the 180, let's see. Okay, so 4 goes into 180 45 times. Okay, and then now what is 21 times 45? 700, no, wait, 1 second. 800, sorry. So then that'd be 945. Okay, and this last one, oh, the answer goes over here. Okay, so the last one you hopefully noticed is not 4 pi, it's just 4. Okay, so you do still multiply by the same conversion factor of 180 degrees over pi. But unlike the previous problems, there's no pi in the numerator to cancel this one out. Okay, so if it doesn't cancel out, you just have to keep it. Okay, so you just multiply straight across. 4 times 180 is 720. 1 times pi is pi. Okay, so the exact answer would be 720 over pi degrees. Okay, so without a calculator, you could estimate what this would be about, right? Because again, we know pi is about 3.14. So you could like divide by 3 to get a rough estimate. But this is the exact answer. Okay. So questions on converting between the two measurement systems. Sorry. Okay, so over here, I asked you to compare them or order them from least to greatest. Okay, so some are in radians, some are in degrees. Again, for this first one, I was kind of nice. I gave you the RAD, but normally you wouldn't see the word rad, right? I would just say 3 and 6. I wouldn't tell you that they're radians. Anything without a degree symbol is radians. Okay, so basically you need to convert these all to the same measurement in order to compare them. Okay, so you can make them all radians or you can make them all degrees. I'm going to make them all degrees, I guess. Well, probably radians is better, actually. Yeah, let's just do degrees. Okay, so we don't pi radians. You might remember that's halfway around the circle, but if not, pi times 180 degrees over pi is 180 degrees. Okay, this one's already in degrees. Great. Okay, what about this one? 3 radians. Again, radians to degrees is times 180 degrees over pi. Okay, but again, it doesn't cancel out. There's no pi up here. Okay, so if there's no calculator, the numbers will be far enough apart to where you should be able to easily figure it out. Okay, so if you look back over here, right, pi radians is approximately 3.14 radians. And we know that's exactly 180 degrees. Okay, so 3 radians is a little bit less than 3.14 radians, right? So this is probably somewhere, you know, in the 170 degree range, maybe 160s. Okay, so we'll come back to that. 6 radians, well, that's double 3 radians, right? But this is somewhat close to 2 pi, right? 2 pi is about 6.28. And we know 2 pi radians is about 360 degrees, right? So this will be a little bit less than 360. Right. Okay, so with that in mind, we can put them into order pretty easily, right? So the smallest out of all of them, we know 3 radians is less than pi radians, right? So 3 radians is the smallest. Next up is pi radians. Okay, next. So obviously 270 is smaller than 300. But then what about the 6 radians over here? Well, 6 radians is only a little bit smaller than 360. Okay, so 270 first, then 300, and then the 6 radians is the biggest out of all of them. Okay, so that's how you could approach this. Again, even without a calculator, the numbers will be far enough apart to where you can quickly approximate where it goes. Okay, but we're gonna skip part B of this section so we can move on to the next part. Okay, so cyclical nature of angles. What does that mean? Okay, so if something is cyclical, that means it sort of goes in a cycle, which means that, it does something and then it repeats. Okay, so we have these things called coterminal angles. Okay, so what are coterminal angles? Why don't we go ahead and define that? Okay, so again, this is not a very mathematically precise definition. I'm just sort of describing it in terms that we can understand at the moment. Okay, so angles are coterminal angles if they end at the same point on the circle. Okay, so a very logical question would be, well, if they end at the same point on the circle, aren't they the same angle? And the answer is no. You can have two different angles that both end at the same point. Okay, so to understand that, let's look back at the first page. Okay, so I told you earlier that negative angles rotate clockwise. Okay, and then I said we'd come back to it. So now is that time. Okay, so let's think about what negative 30 degrees as an angle, what that means. Okay, we already know where positive 30 degrees goes, right? It means go this much counterclockwise, right? So positive 30 degrees is this angle. Okay, and we rotated from the positive x-axis this way, right? So that's 30 degrees. Okay, so for a negative angle, we're going to rotate clockwise instead. Okay, so you still start at the positive x-axis, but instead of rotating counterclockwise, you rotate clockwise. Okay, so you rotate the same amount, but in the other direction. Okay, so this angle represents positive 30 degrees because we went in the usual direction, but this angle represents negative 30 degrees. Okay, so this point right here, we've called it positive 330 degrees, and we're now calling it negative 30 degrees. Right, so the positive 330 degrees would be if you go nearly all the way around the circle and you stop right here. The negative 30 degrees is if you go a short distance in the opposite direction, right? But either way, you stop right here. Okay, so these are called, these two angles then of 330 degrees and negative 30 degrees. These would be called coterminal because even though they got there in different paths, they both stop in the same place. Okay, so how do you find coterminal angles then? Sorry, let me go back to the front page one last time. Okay, so these two angles are coterminal, but it's not just limited to two. You could keep going. Okay, how could you find even more coterminal angles beyond these? Okay, so let me erase so it doesn't get too crowded. Okay, so let me just focus on 30 degrees. Okay, so we know we can get to this point by rotating 30 degrees counterclockwise. Okay, but what if instead you first did a full rotation of the circle and then you went 30 degrees past that? Okay, so you did a full 360 first, and then you added an extra 30 degrees beyond that. Okay, so this 30-degree angle could also be called 390 degrees, right? Because whether you go directly there or take a loop and then go there, right? Both of these end in the same place. Okay, so 30 degrees and 390 degrees are called coterminal angles. They both end in the same place. Okay, so basically what we did was we added a full circle to the initial angle. Okay, so that's the general strategy. To find coterminal angles, you can either add or subtract a full circle. Okay, so I'll write that down. Okay, so that means there's literally infinite coterminal angles. You can add as many extra circles as you want, right? If for some reason you did 5 extra loops and then you went another 30 degrees, you're coterminal with 30 degrees. Okay, so normally we want to get things to the simplest version, right? So we want to go back to being between the first rotation through the circle, so between 0 and 360 degrees. Okay, so let me jump over and do part B of this first section. Okay, so find a coterminal angle of negative 435 degrees between 0 degrees and 360 degrees. Okay, so I'll start by adding a full circle. Okay, so when you add a positive and a negative, right, they cancel out, so you're actually subtracting. And make sure you keep track of the signs. The negative is bigger than the positive. Okay, so negative 75 degrees is coterminal with negative 435 degrees. However, it doesn't fit the requirement of being between 0 degrees and 360 degrees. So we can add another full circle. Okay, so, well, technically it's negative 75 degrees plus another 360 degrees. Right, but it's probably easier to rewrite this as 360 minus 75. Okay, so coterminal with negative 435 degrees are both negative 75 degrees and 285 degrees. But because the answer has to be between 0 and 360, this is the answer. Okay, now what about for radians? So looking over here, 11 pi over 3. So here, instead of adding or subtracting 360 degrees, since I'm in radians, a full circle is 2 pi. Okay, so to find a coterminal angle, I could subtract 2 pi from the original angle. 2 pi is 2 pi over 1. And then when subtracting fractions, we need a common denominator. Okay, so I figured out that 11 pi over 3 is coterminal with 5 pi over 3. But do I need to repeat like I did on the first example, or do I just stop here? I need the answer to be between 0 and 2 pi. Okay, so 5 pi over 3. Here you could temporarily turn it to a mixed number if you want, right? 3 only has one full group in 5, so it'd be 1 and 2/3 pi. So that is between 0 and 2 pi. Okay, so 5 pi over 3 would be the coterminal angle. Okay, there should only be one coterminal angle that is within the range. All right, so go and take a minute and try the rest of those two sections, please.
And if it's to make the common denominator. That's I'm doing it right now. You have to subtract by subtract. Yeah, do you have to add it? Give those.
I did the subtraction. I did with 2 minus the answer. You can add.
Because it's already negative.
And if you add it, it's reverse image just did, right? Oh wait, no. You start like that. And you can add 2 minus here. Oh wait, I don't no way. Oh,
yeah, because in order to get starting negative is yeah, so you're, I guess, very first step is the first based on that. Okay, I'm just gonna write up the answers. If you have a question about how to get to any of these, you can let me know afterwards. Okay, so please be aware that you may think it's being picky, but if you do not put the degree symbol, that will be marked incorrect, because that's kind of the whole point of this, that degrees and radians are different. If you don't put the degree symbol, then you're telling me it's radians. Okay, so just be careful. Let's skip the next section and go to this last one. Sketch the angle and standard position. Okay, so for this one, we're not going to do a circle. We're just going to draw the axes. Okay, so we can start with just the regular XY axes. Okay, so when I say sketch, that means, you know, it doesn't need to be perfect. It just needs to be reasonably close. So mainly it needs to be in the correct quadrant, right? So out of the 4 sections that the 2 axes split the plane into. Okay, so you know that you're going to start on the positive x-axis, and because it's a positive angle, you know you're going to rotate this way, but how much? Well, again, a quarter turn would be 90 degrees. This is less than that, so you're going to go a little bit, you're not going to go all the way to 90, right? You're going to stop short. Okay, so something like this. And then, so I am looking for this arrow that shows what direction you rotated. And then you're going to draw in the, what we call the terminal side of the angle. Okay, so this is all I would need to see. But if you just did say this, if you just did this, that would not be correct because I don't know that you know that it was this way. You might think it was this way, right? So you have to show me you understand it starts at the positive x-axis. Okay, and you do that by drawing the arrow this way. Okay, so now 500 degrees, right? So we just talked about coterminal angles. You know that 500 degrees is coterminal to 140 degrees, and that's true. And knowing this is helpful because, okay, we know 0's here, 90's here, 180's here. Okay, so 140 degrees would be past the 90, but not all the way to the 180. Okay, so you can draw your axes again. Okay, but please make sure you're listening. This would not be correct. This drawing represents 140 degrees. So coterminal angles are not the same angle. Even though they end in the same place, they're not the same angle. Okay, so how do you represent the actual 500 degrees? Well, you don't just turn it into 140 degrees. You sort of split it into 360 degrees plus 140 degrees. Right, because that actually equals 500 degrees. Okay, so the way that you would sketch this angle then is you would first do a full loop, but instead of doing like a circle, you do kind of like a spiral so that it doesn't overlap and get crowded. Right, so that's the first 360 degrees. And then after that, you go an additional 140 degrees. Okay, so from here, right here would be an additional 90 degrees. So a little bit past that would be an additional 140 degrees. Okay, and don't forget, draw the arrow. And then also draw in what we call the terminal side from the origin, showing where the angle ends. Okay, so go ahead and try sketching the other two angles, please. Draw the terminal side. So you do add a whole 360 at first because it's negative. We want to make it positive. So this would be negative. So because it's negative, you can't stop it because it's not a direct angle. So you need to add another. So you add another. So the answer is actually
You go down. You go down and around.
Okay, so let me show you what you should have come up with. This first one, you really don't benefit by converting this to positive 280 degrees, right? Even though it's negative, it's easy to work with when sketching, right? Because if this much is positive 90 degrees, this much would be negative 90 degrees. Okay, so negative 80 is a little bit short of negative 90. Okay, so you would go a little bit less than a quarter turn. Okay, again, make sure you draw the arrow and make sure you draw the other side of the angle. Okay, now over here, negative 400. Here you probably want to figure out the coterminal angle because it's not between 0 and 360. Okay, so if you add a full circle to negative 400 degrees, you get negative 40 degrees. So negative 400 and negative 40 degrees are coterminal. But when you sketch it, you can't just throw away the 360 degrees. You have to include it. Okay, so you would split the negative 400 degrees into a negative 360 degrees plus an additional negative 40 degrees. Okay, so now when you sketch it, first you do a full negative loop to represent the negative 360. And then you go an additional negative 40, which is less than a quarter turn. Okay, so something like that. Okay, so questions on the sketching aspect? Okay, and then this bottom section, you did cover this in your previous class, right? Yeah, so sine, cosine, tangent. We'll get more into those next time.